Design for failures. Anyone who's been around the block knows that the engineer's life is like this. Putting out fires, such as bugs, ugly code. We'll call that unmaintainable code. Sometimes there's more to it where you have to actually communicate the issue. Mitigation plans, workarounds. This is the life of an engineer. There's an article here from Hugo Osvaldo Barrera, and he talks about the idea of the 90%. And he talks about how, 98% sounds like a lot. If someone wins the lottery 98% of the time, they're clearly blessed. And so on the surface, if things work out for 98% of the users, all is well. But unfortunately, depending how big your app is, this can change very quickly. All right, how many users are using, let's say, Cursor? Over 1 million daily active users. Now that's from Google. We'll just take that number. Let's say a bug is introduced that impacts all of the users. That's about 20,000 users. And every case, when they encounter this bug, they're thinking like this: Cursor sucks. The devs don't care. Quality is ass. Right? This is what's going through their head when this happens. And if you have really reliable users that have stuck around from generation to generation, we all have these users. Even in this YouTube channel, there are people that have stuck around through all my crazy takes, which I don't think they're crazy, but it seems like only a few of us think this way. So this is your ideal user. What are they going to do when this happens? They're going to say, report the bug, await the fix. This assumes that they think highly of the team. As the example of Cursor, they're a very talented team. So I think if I ran into this situation, I would say, oh, they're likely to fix it pretty quick if I bring it to their attention. And so this would be the angle to take. But then you have the traditional user, which, let's be honest, this is the average person. When they encounter this bug, what are they going to do? They're going to uninstall, tell their friends, X app sucks, and it may go even deeper than that. And I don't blame this person. I think there's certain products that I've used and I've felt this way. It really depends how much time you had to actually build up a feeling of reputation towards that product, right? But so back to the topic, designing for failures. You need to assume that this is going to happen. You need to assume at some point these 20,000 users are going to be hit with a bug. The article mentions if a website uses a fancy new browser feature that works 98% of the time, they're basically kicking out 2% of the audience. And as I mentioned earlier, this 2% is actually quite a bit as you scale. I think the ideal number, because let's be honest, you can never get to 100% perfect, but even at 99%, 10,000 users is a lot. And so how do we design for failure? Number one is to assume failures will happen. I think any good engineer worth their salt, anytime they add a feature or design something, they're immediately thinking about where this could go wrong. What are the edge cases? If they hit said edge cases, what happens? Right, these are things that should go through your mind at every step of development, really. But even with this, right, we're not in a perfect world. Something's going to happen at some point. That's how it goes, right? Sometimes it might be you had a piece of code that you wrote back in freaking 1990. And this code has just been sitting there forever and ever, and it never anticipated what would come next. And this happens. And so even though this was all thought about at the time of the inception, old code can't predict future. And then number two really is just designing for the failures. And there's a lot of aspects to this. I can't get into all of them, but I'll just list out some common ones, right? Eliminating single points of failure. If you think like a massive company like Google, they don't have just one server. They have a bajillion servers. So if this is your PC, maybe they have like a load balancer. There's so much logic that goes into making sure that if a single server goes out, there's always going to be some backup that you get sent to. You can also think about this even locally. One thing that Mac OS operating systems do, which I believe they use XNU, which is like a hybrid kernel. One thing that's great about Mac and XNU type systems, if a driver crashes here, which this would be the user space, this keeps going, right? This kernel space doesn't just completely lock up. If you've ever experienced a driver error on Windows, it's terrible. On Windows, you're getting a blue screen of death, whereas on Mac OS, you're just getting a crash for that specific driver, which is a really big benefit. Obviously, there's a lot of negatives to the way that macOS does their operating system. But this is just an example of, ensuring that anything could happen, it's going to isolate from the rest of the system. And so that's a big part. Watchdogs and timeouts are a big part of this too. If we assume failure is going to happen, we want to make sure that it's going to have a barrier where it's like, okay, we need to stop checking this. And I think really LLM generated code does this stuff for us for sure. You'll rarely see a case where they don't implement a timeout function of some sort. And they also have the try catch blocks. LLMs are very good at designing for the failures. But there's this common argument going around of should you read the code? I would say if you're gonna read the code, this is the kind of stuff that you really should be focusing on. Is there any point in the code where it looks as though we're just putting full faith in the code is going to work and we're not going to have any kind of backup. And this isn't just about availability. This is also about what happens when it does fail. And so part of, eliminating single points of failure, watchdog, timeouts, that kind of stuff. There's also the aspect of being prepared. At the end of the day, it's going to happen. You could spend every waking moment doing this. And while it's important and you should do it, absolutely. I would even argue you should spend more time on this than you do actually writing the core parts of the code. You have to realize that it's going to happen. And I will say this is an aspect that a lot of people don't talk about, and AI really can't help you on, is learning how to communicate it. If you send me an AI-generated writing about how there was this bug and we're fixing it, I would be able to tell and I'd probably feel really upset about it. And so you need to be able to, be a human being and actually communicate what you're doing in this case, how we are mitigating it, how it impacts you, what we're doing going forward. Right, if you run into a bug and it gets uncovered, your first step should be, okay, what is the impact of this bug? Because obviously every engineer team, their log looks like this. They've got freaking 100 bugs on their to-do list. And so you can't realistically prioritize all of these. And so oftentimes you're focused on the high priority and you'll kind of get to these. And so bucketing this priority as quickly as possible is part of the job. But then even after you bucket it, no matter which area you bucket this into, if it's been uncovered, you need to have some kind of communication on it, right? Because going back to what I said earlier, right, your ideal user will report the bug and await the fix. If they do this part and nothing comes out, they're gonna feel some type of way and they're gonna turn into this devil here. They need to know that you're actually listening to their feedback and you're actually gonna incorporate the change at some point. And so it's important that we document this and get this out as quickly as possible. A lot of programs have things like release notes for this stuff. I will say most people don't read release notes unless they run into an issue. It's unfortunate because a lot of teams spend a lot of time on their release notes. Like they go into super depth of what they've added and what they're working on. But unfortunately, no one's going to read these unless they run into an issue. And so it's important though that if they encounter said issue, because even the traditional user, they might look into it. Right? What is the first thing you do when you encounter an issue? I imagine we're all a little bit different on this. At least for me, the first thing I do is I look it up on Google. It's a simple answer, but 9 times out of 10, if it's a bug that's been reported before, you'll either get a solution or you'll at least figure out that it's known. I think the worst case scenario is that you look it up on Google and you don't find it. That's when it's like, oh no. You're either going to be the traditional user in that case and you're going to uninstall, or you're going to hope that you're an ideal user and you're going to report the bug. But either way, right, you need to be prepared for this. You need to have either a release notes or some way to communicate this portion, because no matter how much you spend here, it's going to happen. There's going to be an issue, and how you communicate it often is the difference maker. I've had times where I purchase something and it comes in like broken or not what I expected. But I've had it where when I communicate it to the company and they get back to me and tell me, hey, let's make this right? Sometimes they can make up for this and actually turn me into a lifelong customer just by handling the situation. This aspect of being prepared is so underrated. It can impact your longevity. And I've discussed in prior videos about how the moat is the longevity, not the product. And what I mean by this is that anyone can release a product, especially in this day and age. There's AI tools that can whip up a product in seconds. But what you can't do is maintain customer trust over a long period of time. This part is what really sets people apart. And it's why a lot of the things that you use have been around for 10 years plus, is because it's been vetted, it's been tested, and the company has continued to support the product, release updates, things like that. Personally, I value this part and I value constant updates and iterations for products that I enjoy. There's a tweet from Theo. I don't normally see eye to eye with his takes, but this one I do agree with. He says, you should be reviewing a much smaller percentage of your code today than you were 5 years ago. And if your code is so important that every line needs to be verified, you better be writing a lot of slop that verifies it too. Right? I actually do agree with this. And it sounds weird, right? It's fighting slop with slop. Obviously, we're using buzzwords here. It doesn't need to be slop. You could put effort and time into this. But this argument here is mainly about, would you or do you still read the code? You should still be writing a lot that goes into the prevention of these issues. You should have always been doing this. Yes, you could argue that now that we have less control over what's going in, we should have even more control on the verification stuff. And I think you should, right? If you're designing code that is actually, you could design number 1 and number 2 above, but there's cases, right? There's security implications. Think about, plain software. Imagine writing on an AI generated airplane code. And the sad truth is, right, eventually AI is going to make it into these systems, if they haven't already. I imagine there's a lot of embedded systems in airplanes, so maybe we haven't quite gotten to that point. But the day will come where we do have some kind of AI written code in there. And so it's important we spend as much time as possible in this prevention stage of just anti-slopping this portion. And I also want to, add some ammunition to this number 3 here. I want you to think about times where companies have absolutely failed you as a user. One that comes to mind most recently, CrowdStrike. If you remember, this was I think it was almost probably 2 years ago now, right? I don't know how long ago it was, to be honest. It felt like a year ago. All freaking Windows machines blue screen to death. This was a big deal, right? The entire freaking planet had issues with their computer on that day. And guess what? CrowdStrike is still in business, and they are still supported by Microsoft, despite having arguably the biggest impacting issue. Just because they did this part really well, they were able to stick around, and they're still used today. And people still trust that they're going to stay afloat. There was also some breaches, like a Visa or Equifax breach. This is a pretty big deal. I think this is over almost 10 years ago now, right? People still use Equifax. And so there's a lot of examples of companies that failed miserably, and yet people still use them every day just because they managed to do this part pretty well. And likewise, same flip of the coin, there's probably companies that failed this part and you no longer use them today, and you might have even forgotten about them. And so whenever you're designing something, I think it's important you focus on these two. Everything that you add in, assume failures will happen, and think about how you can prevent catastrophic failure. But at the end of the day, assume it's going to happen anyway and be ready to go. Right? If you're releasing a product to users today, make sure you have this locked down. You have a nice place where people can report their bugs. Maybe it's GitHub. Release notes that you're actually sending out with every release that actually documents known issues. Right? You should have a known issues and bug fixes section. This is very, very important. And oddly enough, you do not see this with every app. I've seen a lot of apps where it's just straight up, they put what they added, and they try to hide this stuff. But dude, people are smart. They are very, very smart. They will never forget that time where you didn't listen to their bug. And also, they will never forget the time where you actually helped them, where you put out the fire, or you have, at the very least, communicated there was a fire. They'll keep that in their brainwaves forever. So you should be on top of that stuff. And so the takeaway here really is that a big focus on any production system that you're vibe coding should be the implementation of guardrails. If you're gonna put effort outside of the AI generating code, make sure that this is where your effort is going. Think about every place that this could fail. Make sure you're testing for this too, right? I think you don't wanna just test the happy path. I think we're all guilty of doing this sometimes when we're just trying to get a feature out and out the door. Obviously it depends how integral it would be, right? If this was like a button where it's just a UX issue, that would go into my low priority list. And so in some cases, if you're in a time crunch, right, you might just test the happy path. But ideally in every case, and especially if it's a severe piece of code, you should be testing the sad path, I like to call it, right? The path where things do not go as planned. Anyway, if you've changed your design thinking at all with AI, let me know. I feel like a lot of this hasn't changed.